In this video, we're going to talk a little bit about absolute value, and then we're going to practice evaluating an absolute value expression. Now, the absolute value of a real number is its magnitude, or the distance between the origin and the point representing the real number on the real number line. So it's basically like the distance from zero. Another way that it has been defined is that if in fact a is a real number, then the absolute value of a, so here we have our absolute value of a, will be a if a is greater than or equal to 0, and it will be a negative a if a is less than 0. It's a little bit more confusing than just talking about the distance between 0 and the number on the number line. So what does that mean? Well, for example, if I took the absolute value of 3, here we would see that our a value fits into the category where a is greater than or equal to 0. So we would do the first thing. Now, that's telling us that the answer would just be whatever a is. So here we would be able to say that the absolute value of 3 is in fact 3 because our a stayed itself. Now what if we did something like the absolute value of negative 5? Well, here our a value fits the second thing where our a value is less than 0. And so here we'll do the second set of instructions or directions, which means that we're going to take that a value, that negative 5, right? That's our a value. And then we're going to put a negative sign out in the front of it. And what do we get when we have a negative negative? Yep, we get a positive. So negative 5 is actually a positive 5, giving us our true answer. So here we can see whether our initial a was positive or negative, we're still going to end up with positive values. I prefer to think about it as the distance from 0 on the number line, and distance can't be negative. I feel like that way is just a little bit easier to understand. So let's practice evaluating. So here we have the equation, or the expression rather, the absolute value of x divided by x. And for our first situation here, we're told that x is greater than 0. Now because our x is greater than 0, it's going to act like our example, the absolute value of 3. So in that case, we found the absolute value of 3. We were able to just take that and make that the 3. So we're going to go ahead and write that down, that the absolute value of x, let's write the problem, because we want to make sure that we're showing our work. So the absolute value of x over x is going to be x, do that in orange so that it matches what we're doing. So x divided by x, which gives us a 1. So that's our solution there. Now, this second part can be a little more tricky, simply because we have to use what we did with our absolute value of negative 5. And remember, that meant that we needed to use that negative symbol. So if we were just using numbers, if x was a number, then we wouldn't have this problem. We would just know it would be a positive number we were plugging in. But because we're just saying that it's x, and it can be a range of things, that kind of opens the door a little bit more. So remember that based off of what we did for the absolute value of negative 5, we know that the absolute value of x is actually going to give us a negative x. Now, don't be fooled. That negative is going to end up going away because remember, in this case, our x actually negative, right? So here x is negative, right? So don't forget that part. So now we go to plug it in. So we can say that the absolute value of x over x equals, and so this is where this piece right here is going to come into play right now. So we're going to have a negative x, and again, that's our negative, and that's our initial x, and we're going to divide that by x. And here you're going to see that we're going to end up with a negative 1. So like I said, that's a little bit tricky, because if, let me just move this up a little bit, if in fact I had said, if I had said that x equaled a negative 3, then if we had the equation, the absolute value of x over x, we would have put in the negative 3 over 3, and that would have gotten us a 3 over 3, which is a 1. Hey, hold the phone. I forgot about the negative, because we were starting with a negative 3. Man, I almost forgot that. And so we're going to end up with the negative 1. So we end up with the same answer, but it seems like it makes a little bit more sense when we use a number instead of a letter. So I just want to make sure we can follow it, that the places where we were placed that x here, right, and here. So that's why we needed the negative 3, the negative 3, and the negative 3.